This is just a little variation cheat sheet. So we're going to fill it in for each kind of variation. So direct variation, we know that is our y equals k times x. And an example of that would be y equals 4x. Remember, k is just our constant, it's just a number. And so in this example, our k would be 4. And this is an example, like I mentioned earlier, of our linear functions. So if we were to graph this direct variation, it would be a straight line. And a word problem example would be something like this. If y varies directly as x and y equals 10 when x equals 4, find the constant and write an equation to represent the relationship. So we would need to find k by dividing both sides by 14, that's a 14. By 14, I just divide both sides by 14. K equals 5/7, y equals 5/7 times x. Remember, if it's a direct variation, then your x is on the outside, not underneath that fraction. All right, we've got our inverse variation, and that one is an example, equals k over x, and an example would be y equals 4 over x. Again, our constant is k, it's that top number. If we've got some kind of fraction and x is on the denominator, on the bottom, then it's an inverse variation. And our graph would look something like, it would look like our reciprocal functions that we talked about. Reciprocal. This one is linear. A word problem example, if y varies inversely as x, y equals 4 when x is 12. Find the constant and write an equation to represent the relationship. So this time, since we've got k divided by 12 to find k, I would multiply both sides by 12. K equals 48. And then rewrite that. Y equals 48 over x. This would be our equation. Finally, we have joint variation. This is going to be the one, remember, with 3 variables. So we've got y equals k times x times z. Our 3 variables are y, x, and z. K is just a number, it's a constant. So an example would be y equals 4 times x times z. Again, the constant in this example is 4. There is no graph of this. Word problem, if y varies jointly as x and z. So not only are you going to be given the word jointly to know that this is the kind of variation, but you'll also see y, x, and z. So if y is 42, x is 9, z is 7, find our constant and write our equation. So I'm going to divide both sides by 9 times 7, 9 times 7. K equals 2/3. So y equals 2/3 times x times z. All right, finally, this combined variation. We haven't talked about this, but it is on this list to just give you a little insight into it. So a combined variation is a combination between direct and inverse. So you would see something like this. If P varies directly with q squared and inversely with r. So let's set up what that would look like. We've got p varying, so we've got a constant with q squared varying directly, right? So that constant's multiplied by the q squared, and inversely with r. So you can see that we've got 3 variables, so it's kind of like a joint, but instead of them all being multiplied together, that r is on bottom because it's inversely related. Then you would just follow the same steps to plugging in. We've got p is 38.4 equals k times q of 8 equals r is 5. So when you do the math, k ends up equaling 3. So you would rewrite that as p equals 3q squared over r.